Today's presentation is about CAMARA compliant agentic operations with MCP, and all of this work is being presented as part of the OpenOP software development group. So this is a brief overview of the agenda, what we're going to talk about today. Now, by February 2026, we're going to release our first AI modules as a part of the OpenOP SDG. And the challenge up to now was that AI services were fragmented, domain-specific, and hard to expose and share. And although networks are becoming AI native, developers still face some complexities. And let me go through these complexities. The first one is AI service discovery, which is non-intuitive, non-usable, and assumes a lot of prior knowledge of data, configurations, etc. We have also a lot of heterogeneous telco cloud infrastructures that employ heterogeneous tech stacks and processes. And finally, but not least, we have also security restrictions that impede the shareability of AI assets. So, what we strive to do as a part of the OpenOP is to make AI service exposure developer friendly and standards based. And we have three main pillars. The first one is interoperability, the second one is openness, and the third one is developer usability. In this way, we try to bridge intents, APIs, and AI exposure. Let me go into more details about the actual problems and the solutions that we propose. So the developers right now must learn and use many APIs, as we all know, and this slows down the development lifecycle a lot. And for the development of agentic applications, this requires custom integrations with telco APIs. And this doesn't only slow down development lifecycle, but also impedes the interoperability between different systems. So we have some issues from functional perspective now. And the proposition is to bridge agentic AI with user experience-driven user interfaces. And let me go through the actual flow. So the users in the first place express their intent in natural language. And then we have the model context protocol, which is well known and was introduced by Anthropic in 2024. And basically is a standardized way for the LLMs to interact with external APIs. So in this way, we abstract technologies and API technology and API complexity. And in order to put everything into perspective, we have the CAMARA standards, which harmonize telecom network capabilities through well-defined APIs that work consistently across different operators. And at the same time, on top of the CAMARA APIs, we have MCP, which provides a structured framework for AI systems to interact with external tools and services. And in our case, we have the CAMARA APIs. And I have also, as an example, a simple user story where the developer queries a natural language that wants to optimize the video streaming for low latency users. And under the hood, what is going on is that the MCP agent is being invoked, then interacts with the MCP server, and the MCP server maps to CAMARA call-on-demand API calls, and these are being executed by the network. So all in all, what we're trying to achieve is to democratize and simplify access and enable AI-driven API orchestration. Okay, and let me provide you a quick update of the CAMARA of the MCP and CAMARA integration status. So CAMARA and MCP standardization are still in early stage. They started in September 2025. Currently, only 15 MCP tools are mapped from 9 CAMARA APIs. We have also 7 MCP resources for state management and 8 MCP prompts for common operations. And a lot of work is underway to integrate other CAMARA API calls to the MCP ecosystem. And in this slide, I have put side by side both the CAMARA Open API specifications for call on demand This is the latest version, by the way, 1.1.0. And on top of it, we have the CAMARA API to MCP tool mapping for call on demand. And as you can see, there is not one-to-one mapping for each one operation. Let's say for the last one, to retrieve call on demand sessions using a device identifier, there's no equivalent for MCP tool. We anticipate in the future this will be amended and improved. But there's a lot of room for progress. And right now, I'm going to present you the software architecture and the tool stack that we used for the proof of concept that I'm going to showcase after this slide. So in this figure on the left-hand side, starting from the bottom, we have the 5G core functions. On top of it, it's the 5G, it's the OpenOP software stack. And on top of the OpenOP software stack, we have the MCP enablement module. So the MCP enablement module will be one of the modules of the AI modules that are going to be released as a part of the OpenOP SDG. Some more information about this module is that it's based on FastMCP Python SDK. We try to provide conformance to CAMARA specifications. So we provide strict data schema validation using Agentic. For non-standardized operations, let's say for retrieval of quality on demand based on device IDs, as I showed before, we will use custom tool definitions. And for the debugging, we're using the MCP inspector, which is a well-known tool to debug MCP servers. Now, on the left-hand side, you can also see the AI application, where we're leveraging OpenWebUI. Again, it is one of the most well-known AI applications, which works with batteries included, which means that it has a lot of integrations with, let's say, LLMs, whether they are proprietary or open source, with MCP servers. It also provides a really nice user interface where you can write your queries in natural language. And the actual interface between the OpenWebUI, the MCP server, is via the streamable HTTP transport. Okay, so this is the time for the really quick demo. As you can see, this is the user interface of OpenWebUI. The LLM that we're using is GPT-OSS 20 billion from OpenAI. And we have also registered the OpenOP MCP server. And of course, it has also discovered the relevant tools. Okay, give me a second to run it. Okay, so the first query is to create a quality on demand session for a specific phone number with quality of service video and duration 1000 seconds. And this is fully compliant to the standards of the CAMARA MCP. So give it a second, it creates the quality on demand session and responds with a session ID. As you can see, the JSON format is compliant to the CAMARA specifications. And then, as a follow-up, we have a second quality on demand session for another phone number with quality of service voice and duration 300 seconds. Okay, and after this invocation, we also would like to retrieve the details for both phone numbers that we queried before. Under the hood, let's say two API calls are being invoked towards the backend of OpenOP. Okay, as you can see, this is the response in tabular form and also the JSON data that are being ingested into the LLM and are being presented to the user. Okay, that was the demo. It was really brief and nice, but let me provide you some insights based on this. So the effective use of LLMs and agentic frameworks still requires a lot of experimentation and iteration. And the reason is that we observed several key issues. The first one was the incorrect tool invocations, especially when multiple tools are semantically similar. Let's say you want to get quality of service information for session ID and quality of service information for a device. There were some times where you had incorrect tool invocation. So a workaround is to have more precise and more concrete specifications of doc strings, which are related to the relevant documentation of the tools. And a very important one is schema mismatches, where the data provided didn't conform to the expected structure. And on the right-hand side, as you can see, this is the actual data format for the device as defined by the CAMARA MCP specification. As you can see, the phone number is nested inside the device field. So sometimes, most of the times basically, it was working properly, but in some cases, the LLMs couldn't interpolate correctly the phone number field. And yeah, all these systems are of stochastic nature, so I cannot explain why this was happening, but that was the end result. So some of these issues, however, can be mitigated, and there are two ways to do so. The first one is providing clearer prompts and better tool documentation. And the second one is to ensure that the LLMs are designed for agentic operations and are properly configured for function calling with the defined schemas. And finally, I have some open questions for the community, is whether we can safely omit fields or use semantically equivalent terms without breaking functionality. And this boils down to the reasoning capabilities of the LLMs. The second one is for verbose API requests, let's say for post operations. Is it practical or scalable to maintain a one-to-one mapping between all fields and their natural language descriptions? And at the same time, if you start omitting fields, you lose a lot of functionality. And finally, how can we successfully debug behaviors that inherently stochastic in nature when you incorporate LLM into your development workflow? So that's all from my side. If you have any questions, any remarks on the presentation, I'm happy to hear.